Okay, nice. There you
All right, we're
go.
back.
Let's pull up. Okay, so for number 5, it says number 4, my bad. Which of the following structures represents the same stereoisomer?
Let me bring it up. To upload my device. This one.
Yeah, nice.
Mhm.
Okay, perfect.
Production value went up since last time.
Okay, so why is this so quiet? Can you guys
Is
hear
it?
me?
I can hear you. Yeah. Can you hear me?
Okay, just
Yeah, I can hear you too.
Okay.
okay, perfect.
I'm just gonna be mute because I have my dogs.
No, you're good. Okay, we can start off with this. What method do you want to do? We could just assign
You can go
priorities
left to
at
right. Yeah,
least.
just assign handedness basically.
Okay, so let's do
Rank
OH
them.
will always take priority. Hydrogen's always the lowest. This is going to be the second priority because of the 2 carbons. Oops. And then, okay,
You know what threw me off? I saw bromine one time, and in my head I just put it number 2, but bromine is like
is
super like
higher.
super number 1.
I
Yeah.
know. In my head, automatically, oxygen is like
Same.
the best bond,
It's
the
like the king
best
of everything.
everything.
Yeah, yeah.
So it's valid. Okay. And then if you were to count, you would go, let me change the color. You could just kind of, oh, that's a bad color. Frick. Okay. And if you were to count, you could just count clockwise, leaving that at R. So we can
Uh,
write.
1, 2. Oh yeah, that's a good one. That's an easy one.
I forgot your technique again.
One,
Oh, wait, you're supposed to switch
two.
3 and
On
4?
this one, it's so basically you only really need it when your lowest priority is not on the dash.
It's
If
not on
you're
the dash. Let me
Yeah,
write that down.
if your lowest priority is on the dash, then whatever you see is what you get, basically. Um, if your lowest priority is not on the dash, that's when it can get tricky,
Change the
or you might
2
get it wrong.
groups.
But on this one, thankfully,
5.
like the hydrogen is always on the dash, so it's kind of easy here. How does this work?
Does that make sense?
If your lowest priority is on the dash, change the 2 groups to have the lowest priority ranked 4. Uh-huh.
Okay, there you go. R
And
equals
then
clockwise, and then S is going to be, looks like a 5. That's an S.
S, where's this? 1, 2. Yeah, this is a good one. 1, 2, 3, 4. Yeah, so these are not bad. All S. So then the same ones are 2 and 3.
Yeah, nice.
Wow.
I think that one was pretty easy.
Yeah, that's not bad.
Okay, cool.
2, 2,
Okay. Now let's go to the second one.
2, 2.
Okay, 5. Which of the following bonds circled vibrates at the highest frequency? Highest frequency is going to be the one closest, is going to be the group closest to the 4,000 range, right?
Mm-hmm.
So if I look at the,
Furthest right. This one, I don't know why this one really stuck in my head when she said it during lecture.
I
Um,
mean,
like when she said the ranges, like I just remembered them for some reason. For like this
lucky.
the C C double bond CH and then C triple bond CH. Basically, it's this one. I think I wrote it down somewhere.
But I'm pulling up I'm trying to find the
Trying to
charts.
find
Oh,
what I
there you go.
wrote. Yeah,
Did
she
I?
said this was like 3,300. This was 3,100, and then this was 2,900 through 3,500. Wait, that's
Okay,
wrong.
I completely lost the charts. And then the,
She never mentioned this one, so I don't really know what that
the
Wait, what
H3.
even is that? What is that? Oh, H4, just the methyl. It's probably lower than I'd guess.
Wait, how did you ranked number two based off the CH bond or the H to H is not a thing, right?
The this bond. Like that. Oh, this just off that.
Okay.
I don't know what slide she was looking at. I wrote this down during lecture, Tuesday, I
Because I
believe.
see here the carbon to carbon bond is, I mean, the carbon to hydrogen bond is 2850 to 3000. Oh, CH2 you meant. No? I'm confused.
Um, okay, what's confusing? What did I?
Wait, where did you find
This
2900 from?
100. This I just wrote down. I copied what she was saying.
Oh,
It's like 29,000 through something.
29,000. Let me
Was
see.
it one of the ones that she wrote on the board, or she was just saying it?
She was like writing it on her paper. Like she was just going through all the. It was like the most recent IR little talk that she gave.
Then
She was
that's
just
most
talking about it
likely,
too.
yeah, that's most likely the alkane carbon to H bond, which is stretching 2850 to 3000.
SP bonds.
I would say
Let me
so.
see. Carbon hydrogen SP bond
Because
IR.
this C to H, this is gonna be alkene.
Yeah, I can't find it. Do
I should low-key join on my tablet. Okay, that's alkene. This is alkane. The CH value is on the alkane part of the chart.
mm,
I'm sorry, this is a really bad spelling.
no, you're good.
Okay. And then the
Mm,
CH is gonna be an alkyne. So
alkyne.
this is the alkyne value. Okay. Which is, well, these two, okay, yeah, are obvious based off the double bond.
Mhm.
I don't know what this would be. The CH3, because CH3 is 1375 to 1450, but connected to a H, I'm not sure what that would be. It is an alkane.
Bond strength. Okay, what about the what about this thing? What about the this?
How do I?
So if we just go off of bond strength, right? Because this one has the weakest bond, you're gonna have a really small frequency, right? If
How do
you have a
you, sorry,
uh-huh.
I was gonna ask, how do you know how to plug in which number to the formula?
This is just over numbers, this is just like guesstimation, like rough estimating. Because the
Okay.
mass is the same. It's always a carbon, it's always connected to a carbon, right? Like
Yeah,
the hydrogen and the carbon, it's always hydrogen and a carbon. Um, so the mass is always the same, but the bond strength changes. So because this carbon and these two carbons on the alkyne or on the triple bonded carbon, I don't know if it's alkyne, are so close together, they're kind of pushing out the hydrogen, right? Because there's a lot of there's a lot of how do you do this? Like, oops, okay, it doesn't like me drawing on it. There's a lot of negativity on the left-hand side of this molecule, right? And there's more
yeah,
positive on the right. So they're more spaced out. So in my mind, that just sends like a weaker bond, right? It's easier to pull off.
yeah.
Um, so that means this number will be small, a small k, a small number divided by whatever, you're gonna get a small weight
Frequency
number.
value.
Hmm.
Okay.
And then that low key, like that's even without looking at the any numbers or anything, you can just sort of gauge that. And it kind of plugs into this.
Yeah, I mean,
56.
yeah, looking at the question, this one has the highest value if you were to look at values.
Mhm.
you kind of just estimate. I don't know I don't know what this is.
The numbers for that?
Yeah, I could probably ask her.
I don't know. But I'd guess that would be the strongest carbon hydrogen bond out of all of them, right?
Yeah, for sure. Okay. We can move on and I can ask her on Tuesday.
Okay.
Okay, number 6. Which of the following bond undergoes stretching at the highest frequency? So I can give those values. Um,
Yeah.
OH is 3200.
Yeah, OH is the big one.
So let's write, I'll just write the value right here. 3200 to 3650. And then you
OH
have,
is usually the big one like this, right? Like it's
yeah,
like
the very broad.
the really broad one
So it's quite easy to,
to spot.
okay. See, carbon to H is going to be 27 to 3350. Okay, and then I don't know how to move this. No, I lost it.
C double bond O.
Okay. A carbon double bond is between 1630 to 1250. Oops, 1820. I mean.
Oops.
And then a carbon, that's a triple bond, right? Yeah. And then an alkyne would be 2100 to 2250. There you go.
16. Really? It's that far back.
Yeah. I think the order was, it was like double bonds
Flop,
somewhere in the middle. And then
flop.
was it triple bonds? I forget.
This one would be the triple bond one. This would be the
Okay. So looking at undergo stretching at the highest frequency, I would pick, yeah, A because of OH. Because of how broad the wave is.
yeah. And then it kind of makes sense too because you have oh no, actually this is one that she's okay, I'm not going to talk too much, but she was just saying that this one you just had to know off of the
Off the peaks?
off the numbers, like off the numbers. Like
Oh,
this
okay.
one doesn't fit. It's not so obvious when you're looking at the formula. Like there's something special about it she was mentioning. It's kind of like an outlier, she said. When
Okay.
you're comparing it to like a CH or something. Because your mass is bigger, so you would think, you know. Okay.
Yeah. Like for 5 is different because they're all connected. It's all a carbon to a hydrogen, whereas these ones are all connected to different atoms.
Hmm. Oh, I
Okay.
see. Yeah. Carbon, hydrogen.
I don't know why I cannot hear you guys, like barely.
Really?
It's so quiet.
Maybe you can is there like a zoom setting?
I don't know. Let me see. I'm like trying so
Was it
hard
louder
to.
yesterday or the same?
Huh?
Was it louder yesterday or was it the same?
Yeah, I feel like it was louder yesterday. Oh, like, okay, never mind. I can't change it for now. I'll do it later.
Okay. You sound fine, so
Okay. Number 8.
strongest acid.
Wait, I thought we are doing 7.
That was 7, no?
That
Did I
was number
skip?
8. That was
Oh, I did
6.
skip. Well, spoilers.
7 is how many stereoisomers of 4-chloro 2-methylpentane can exist.
How many isomers of this? Let's draw it out.
That's the formula 2 plus, no, n plus 2n. I'm forgetting the
How
formula.
many stereoisomers? It's just basically, oh, n plus 2n?
Yeah,
Isn't it just each,
isn't
if it
doesn't that
has
tell you how many
if it has one chiral center, it can have two, right? It
Oh
has two,
wait,
so it's
it's
just times
this.
two to the n,
Yeah, that's
to
that's
the
how many
n,
so
2n.
however many chiral centers you have goes here,
Hmm.
and that tells you how many stereoisomers, right?
Yes, yeah, yeah.
Yeah.
Okay, there you go.
I can attempt to draw. Man, this condensed formula is the worst. Okay, I'm gonna draw this carbon first, and then it has. Wait, can you can you move your mouse?
Yes.
There you go. That sounds high maintenance, but it gets in the way of
There
my
you go.
pencil. There's two methyl, and then it has one like that, and one like this. Then there's a Cl, and then like that, right?
For 7? Oh,
Yes.
yes, you're right. Sorry. I didn't see the CO.
Methyl carbon. There's one,
1, 2,
two,
3,
three,
4,
four,
5. Yeah.
five, six. One, two, three,
1,
four,
2,
five,
3,
six.
4. 1, 2,
Cool.
5. Yeah.
And if we play the spot the chiral center game,
Should I highlight the H's or no?
I think at this point we can imagine them. But
Okay.
I mean,
Let me.
yeah. I guess for the sake of the chiral center, we can draw the chiral center H. There's an H somewhere like here, right?
Okay.
Yeah.
And then your other. So, yeah, one just literally just one chiral
Just
center.
that one, yeah.
Okay.
This one has two identical methyl groups, so that wouldn't make sense.
Yeah, so you can only have two stereoisomers because there's only one chiral center.
Mhm. That's 2 to the power 1 equals 2.
Okay.
Ta-da. Cool.
These are not bad so far. Like
Yeah, these are
multiple
easier
choice.
than weirdly easier than yesterday's.
Yeah. Okay.
Right.
Because I was like, this was kind of like ex self-explanatory.
Yeah.
I don't think we're supposed to look at 8,
Oh,
right?
not 8?
Yeah,
Okay.
so we go to 12 through 16 now.
12 to 16.
Yeah, 12 is which what is the
Oh,
hybridization of carbon atoms labeled I, 2, or 1, 2, 3 in the following structure?
3B. This should be free points, y'all. No one should miss these.
Should I try to draw it? Oh, never
Boom,
mind.
right there.
Okay, we can go like this.
Maybe we could draw like the expanded version of it, so maybe it's like a little more obvious. Ba, ba, ba. It looks like that. H.
Yeah,
Like that. There we go.
okay. And if you look at this is gonna be I, this will be this will be 3. Okay. Maybe we can highlight the orbitals. So you have for carbon 1, 1, 2, 3. So that's sp2.
Hmm. For the second one, you have 1, 2, 3 as well. So that's also SP2.
Wait, are you doing this on your iPad?
No, I have a like a drawing tablet for
Ah,
drawing.
lucky. Okay, I was like, how is your
Yeah.
structures coming out so nice? Okay. Um, okay. And then number 3 is gonna be just 1, 2, 3, 4, which means it's sp3. I just remember if there's 4 bonds, your sp hybridization number is gonna be 1 less than it. So
Yeah, one less.
just in case it doesn't,
It's not clocking for someone.
yeah, it's not
Yeah.
clocking.
It's not clocking.
That was me in the beginning of this class. I was like, what? Okay, yeah, SP3. Nice. Okay,
Okay.
12 is done. Let's go to 13, which is
6,
what is
8.
the index of hydrogen deficiency of a compound with a molecular formula of C6H8?
Okay, so it's just
Oh, I forgot to study
index
this.
hydrogen deficiency. Hold on, I'll just write it out because that one's simple enough, I guess. Index of hydrogen deficiency. What's the formula?
Um,
C
C6H8, sorry.
H8.
Yeah.
Okay,
You're
let's
gonna have
do.
to take over this one because I haven't studied it.
Okay, cool. Let's do index of hydrogen deficiency. So we have over 2. We have our ideal hydrogens minus our actual. And the ideal is based off of like if there was the max, it was fully saturated, right? And it's called the formula for an alkene.
Do you
Alkenes.
think she'll make us do the degree percentages? Like write out the whole, like how we did on the worksheet on worksheet 7? Is she gonna make us like write out which degree?
Probably. I feel like that worksheet is exactly. We could go over that. I did want to go over that. Um,
Okay.
yeah.
Okay.
What am I doing? Okay, alkene. Yes, alkene is CnH2n plus 2. That's your formula, right? So this is how you find your ideal. So first step is we just look at our let me use blue. We just look at how many carbons we have. So we have 6, right? So you just whip out your calculator or your internal calculator, C6, H2 times 6 plus 2. So ideally, this carbon would have 14 hydrogens, right? This molecule would have 14. So over here, I'll do to the right. Ideally, it would be 14. But actually, we have 8. That is what actually exists, right? So that equals, don't embarrass me now. What's 14 minus 8? I'm not a mathematician. It's 6 over 2. Yeah, there we go. And then that's our 3, right? This is our index of hydrogen deficiency. Is that all it was asking for? Oh, you're muted.
Yeah.
My
Yeah.
bad. Oh, you
Uh,
didn't even hear what I said this whole time. Yes, that's all I was asking
okay,
for.
yeah, that's all I was asking for. Okay. Now, I guess before we move on, what does this even mean? Do you know what this means?
What do you
The
mean?
de
Hyd
Yeah. What does it actually mean? Like, what does that mean about the structure?
the degrees of the structure. Like,
So
I
it
know
means,
the ring is 1 degree, and then the double bond is actually I have it on my note.
mhm.
Um, yeah, double bond is 1 degree, triple bond is 2 degrees, and the ring is 1 degree.
Yep.
Yeah, so it's
Combined.
basically the degree of unsaturation.
So in this case, we could have like 2 pi bonds and like 1 ring. It could be. It could be 3 rings. It
Yeah,
could be 3 pi bonds, right?
Yeah.
As long as it
yeah,
just adds up to 3.
yeah.
Mhm.
Yep,
Okay,
perfect.
cool.
Okay. That was that was
That was
13 or that was
13.
14. No, that was 13. 14 is
14.
the same thing.
Oh, but there's bromine. Okay. Should I write those out to the groups?
Yeah, why not?
So there's one,
Yeah.
there's just the extra rules. I'll write it under, I guess. Um, right here. Boop, 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 boop.
Here I can write.
Our group 7 plus 1, our group 5, our group, oops, group 6. Group 5 equals minus 1. Um, Let me just double check I have that right. 7 plus 1, 5 minus 1. Yep, like that. So this is our group elements. Uh, so if we have a group 7 element, we add plus 1 to the actual. if we have a group 6, like an ox, I could write out some like oxygen, sulfur, 7 is fluorine, chlorine, bromine,
Periodic
iodine,
table.
nitrogen, phosphorus, right?
Yeah, nitrogen and phosphorus.
So if we have a nitrogen or phosphorus, we subtract one from the actual.
Yes.
That's how that goes.
So if bromine is included, that means we're adding one. Oops,
We're
that's
adding
too
one to the
small.
actual.
I actually have like a kind of a simpler formula if you guys want me to put it down.
Yeah, of
Okay,
course.
yeah, what is it?
Um, Let me see if I could type it. I don't know if this kind of works. Okay. Oh, it's gonna kind of be big. The du and then 2c plus 2 plus how many nitrogens? Oop, that is not good. You guys can understand that, right?
Yeah. Plus how
Uh,
many nitrogens, right?
uh-huh.
Yeah. And then minus the hydrogen, and then minus X will be halogen, and then over 2, if that makes it more simpler.
What about the phosphorus?
That's the halogens, the X
Uh,
hal
phosphorus is not a halogen.
oh
Wouldn't it apply under, I'm assuming, the N, the same group? Is that what this formula is kind of
Oh, is that
like?
what the N is supposed to be, like the group 5s, you
Yeah,
mean?
it's supposed to be like
yeah, yeah, yeah,
representing.
yeah, yeah. Sorry about that. Yeah, yeah, I
No, that makes sense.
sorry. Sorry if that didn't clarify. But does that make it kind of like simplified?
Minus
I don't
2.
know. This the one that she gave. I don't know. I feel like that's kind of confusing, but this one kind of helped me.
No, this one
It
makes, I get what
it
you're,
works. Yeah.
yeah.
I feel like in my head, seeing this like ideal minus actual over 2 is pretty simple. And then all you have to do is either add 1 or subtract 1 or do nothing to your actual number, right?
Okay. Yeah.
But if
I,
you can you type it out like with the text, that formula? 12 minus what is it? 9. Oh, actually, oops.
12 minus 5.
9 minus, oh, I'm looking at the example you gave. This was the ideal that I calculated right there. Because this was your example, right? This one?
Got it. Yes, 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 sorry.
Yeah. So it was like 5 times 2, 10 plus 2 is 12 ideal hydrogens. And then 9, actually, no, not minus, plus 1 over 2. So that's going to be, uh, oops, 2 over
Got it.
2
I see what you,
equals 1.
so you only have 1 degree.
Index of hydrogen deficiency.
That's 1 degree, right?
1 degree. Yeah. So that means there's either one ring or one pi bond.
Yep,
Cool.
perfect. I mean, either or formula I think works for depending on how you look at it. Very
Yeah.
nice. Okay, we're good to move on?
One. Yeah, I think so.
Okay. We
What's next?
have 7 minutes. Okay, that was 14. And then we're going from,
15.
oops.
Maybe we have 7 minutes, you said?
Yeah,
Do you want to skip? I mean, 15 is more the same and it's like the worksheet. Do you want to do 16?
sure. I really get 15. 15 is, yeah, the same thing. So, the following substitutions has the highest priority according to the Kahn-Ingold prelog system using and
I'm gonna
assigning E
move
to
to the
Z.
right. There we go.
Oh,
Oops,
nice. Okay.
over here.
So this is the
Okay,
second
what is it even
formula that
asking?
can be used.
Oh, this one. N plus H
Okay.
plus N. And then this N could be N or phosphorus, right?
Yeah,
Yeah.
it's to represent group 5.
Group 5. Yeah.
Okay.
Group 5.
And then which of
Which
the
of the following
following
substitutes
has
is highest
priority according to the Kahn angle system using the E and Z configurations of carbon?
What is that even asking? Oh, okay.
You're
I
looking
see, I
at
see.
the like you remember how it was like E and Z are like cis and trans,
The
except cis
like
and
if it's
trans
saying
requires like two.
like if there's a question marks here, right? Whoops. There's
Yeah,
like
which one has the highest priority
groups. Yeah, which group would have highest priority? Um,
based off the double bond? What am I doing?
so
Sorry.
this is just more ranking, right? Like when you're doing your S or R chiral centers, just more ranking. Um, this first carbon has a carbon and a hydrogen attached to it. Oh, it has two carbons. Two carbons and a hydrogen attached to it. This carbon has an oxygen and two hydrogens. This
I mean,
carbon has two. I mean, it's just pretty.
yeah.
Yeah.
I feel like just looking at it, the two biggest groups that pop out are going to be the oxygen right here and the bromine. And
And
if
then you
you kind of
just,
just look at their atomic mass, you should be able to identify that bromine is stronger. So it'll give a higher priority.
yeah, D.
Yeah. I feel like this one is also somewhat straightforward
I think so too.
if you're just looking out of your group
Uh-huh.
options. Okay.
Man, we like ran through these ones.
I know. I mean, these ones were kind of repetitive in a sense
Yeah.
to
Um, just ordering IR. Definitely we need
see. Okay.
listen to what
First
she
one's
says
two
on
five IR.
Tuesday or Thursday for the flashcard because we'll see.
Oh, yeah, she's gonna talk about it, right?
It has to be Tuesday. There's no way. We have the exam on Thursday, so
Yeah.
uh,
If not on Wednesday night, she makes these something.
is it
Okay,
after
we can go over number two for the nomenclature.
nomenclature 2.
Yeah.
Let me see.
Are you able to post a picture or should we draw it?
I can, yeah.
I don't know where you are on the thing.
Under 16, under that problem.
Okay.
Let's
Okay.
see. 3 minutes. This one, right?
Yeah. Perfect.
There we go.
Okay. So let's go black. The question asks, write the correct name for the following structure or the correct structure. Okay. So if we just start off with assigning priority, we can see one, and then my double bond is right here because we want to give it the lowest set of numbers.
Hmm.
3, 4, 5. So that's a pentane or pentene. Wait.
Pentene. Yeah.
Yeah, pentene. Okay, I thought it was wrong. Okay, and then
Never.
okay, and
Oh,
then we see that the double bond is on 2, and then you have a methyl on your third carbon. Getting bored.
I'm, I'm listening to you. It's like
No, you're good, you're good.
one,
I'm just saying it for the sake of the video.
2, 3.
Okay, so if you were to list it following the rules, you're gonna start off by listing um, the lowest alphabetical order. So I'm gonna say that before I say if it's E or Z, I'm just gonna start off with saying what the
Oh yeah,
structure
that's
is.
right. Let me draw the imaginary hydrogen. It goes like this. Boop.
Pent E. Right. Oops.
3-methyl,
Okay, so
2
this
pentene.
specifies the 3-methyl, and this is gonna be the
1 minute.
2-pentene. There you go.
No rush, but rush.
Sorry,
Okay.
what?
I
I
said no
cannot
rush,
hear
but
you.
I said no rush, but rush to 1 minute.
Oh, shoot. Okay.
Okay.
Um,
And then the E or Z, right?
yeah,
I
either.
think
Yeah.
E or Z. Yeah. So then we
Uh,
just pick uh Z means on the same side and E means opposite. um, because Germans have a strange language.
What if someone in this class is German?
And on the same side, that's how I actually do remember. Like, I say same side.
Oh, that's a
Okay, so the
good technique.
two big groups, we have a big ethyl group on the left, and compared to the hydrogen, this methyl group is bigger, so they are on the same side. So it is
Same.
Z3 methyl.
Okay, nice.
We did it.
Getting creative.
Z. And you
Okay.
don't need to number it. You don't have to say one Z because there's only one double bond. So you don't need to specify that, 2Z or whatever.
Yeah.
It's
Okay.
just one. Perfect.
See you guys in
I will
a
Z you
minute. See you later.
in a
Okay,
minute.
whiteboard. There you go.
Perfect. We're back.
Okay.
Okay.
So we last finished 2, and now we're on 5.
We finished two. We are on for naming.
Yeah, but we're on 5. We're on 5.
Okay. It just says, what is what
Allow
is
Allyl
what is this?
allele cyclohexane?
Allyl. What is this? Allyl. Let me upload.
I have never heard of that in my
I
life.
have never heard of that either. We are all
Um,
failing the exam. Allyl.
is this
Well, I
even
know what a
worth doing?
cyclohexane is, but
I guess it's almost kind of like
that's
a
mean. There's no way
ethyl.
she would put that.
I don't
So
know. Let me search
according
up
to
what
her,
that
I mean,
is.
you can see the drawing, right? You see the
Yeah, it looks like it's almost like an ethyl, but it's not.
it's like an ethyl with a double bond at the end of it, right?
Allele.
Allyl, allyl, allele. We are incorporating biology
It's an
right now.
unsaturated car hydrocarbon. I guess it is a real thing.
It looks like this, like that, right?
No, you have to make it. It has another
One more.
carbon bond. Okay, yeah, an allele is a CH2 double bond CH to a CH.
Okay, that's mean.
CH2, I mean. Okay.
If she puts that in, she's just looking for the nerds, basically.
Yeah, that's so foul.
That's so messed up. This is
For
an
them.
allele group.
Yeah, I'm not sure why she would have us do this. Okay, but
Me neither.
anyways. Oh,
What happened?
we were supposed to explain. Oh, she connected this to a chair confirmation.
Yeah, it says the question is draw the most stable chair structure. That is the
Oh, that's
question.
right. Okay, well, we know the most stable chair structure for cyclohexane is gonna be chair because it has what is it? What did I say last time? Cyclohexane's
I don't
bond
remember.
angle is 120 and you want to be closest to 109.5. That's why the chair structure is most stable.
Mhm. And then this could either be up or down. Wait, the most stable. So we're free to number it. We're free to put it wherever we want. It just
Yeah.
has to be the most stable, right?
So most stable will always be equatorial.
Hmm.
So if you draw it, whoa, that's really thick. Jump scare. Okay, let me do this again.
This is a really nice
I know.
set of
You did
drawing you did.
this?
Yeah, I know, right? All on my own. I'm all grown up.
You're gonna get an A on the test then.
There we
Oh,
go. Nope, perfect. No, no, it was perfect.
there you go.
There we go.
Okay.
All right, so apparently that's an
Allele.
allyl, allele,
Yeah.
an
I
allele.
don't know how to say it. I've never heard of it. But you just have to know that the cyclohexane's most stable is your chair, and then you just attach its functional group.
Okay, cool.
There you go. What is that? Looks like bio.
It's an allele.
Yeah, I'm like, I was looking at that. I was like, wrong class.
Okay, what's that?
Okay. And then the last the last set of questions that we're working on is going to be question 2 from the, nope, never mind, the IR spec.
Spectra.
Yeah,
Um,
which is all the way at the bottom.
that number one.
Wait, she didn't specify.
She just said Spectra, right? We can work on this
Yeah,
then.
we could do 1 or 2. I don't
Yeah,
know.
let me pull up one. I genuinely, you're gonna be the one yapping here because I'm just following your lead.
Jump scare. In
Just
that case, pick
boom. I picked one. Oh,
Oh,
one is kind of
okay.
easy, I think, because of the OH.
Okay.
Now let's do one anyway. Why not?
Okay, how do I zoom? Oh, nice. There you go.
Insert
Okay.
device.
Let me look at the.
Okay, we have to memorize all the frequencies.
No, don't say
Yeah,
that.
you do. All right, there we go. Oop, no,
Okay, are you able to, any chance make it a little bit bigger? Actually,
bigger.
maybe I don't need it.
I can make it bigger, like that.
Yeah,
It's
perfect.
a lot bigger.
Okay. Um, let's just look at this one.
Let me
So
label
looking
things.
over here, we see that it's in the range of the 3000. This
Spiky
to
3000.
me looks like, sorry, what?
I'm just repeating. Go, just keep talking.
Sorry. Okay, this to me is a CH represented
Really?
because if you look at the CH bond on the
So
on the
strong.
alkene, it's 3000 to 31.
Hmm.
So if you look, let me look closely, actually. Hold on.
There's
Actually,
nothing really going on in the
my
quote
bad.
unquote fingerprint area, is there? It's
Yeah, this
kind of
kind of,
empty over here. I
let me
mean,
just
except
look
from
at
this
this
thing, I
one.
don't know what that's supposed to be.
Yeah.
What is that?
So, sorry, this one, this blue one right here is, oops, is not an alkane. It's an alkene because if you look closely, it's between the 2800 to 3000 range. So
Hmm.
will be your alkene that's sitting right here because it starts off like right here if you look really close.
At the 28. Okay.
Yeah, there you go. Perfect. Okay. And then right here, I'm gonna look on my iPad so I can actually see it. Okay, it's kind of around the 1550 area. So looking at your chart,
Is that just gonna be carbon-carbon bonds or
carbon to carbon bond, you usually can't really see it.
okay,
So it
my
should
my my
be,
guess in off the bat, my guess is that this top one is just the hexane. Right? That's
wait, which one? Oh,
there's two options at the bottom.
oh, you're supposed to pick? Oh, okay.
I get to match them. But you also have to explain, the question says that you have to explain your reasoning, so it's not enough just to guess.
1550. So I would say
I would guess.
that this could
That's
either
what I
be
thought.
a CH2 potentially
Mhm.
because it's before the 1550.
Mm. Yeah, it's like right
Um,
before it.
yeah. It's right before it and it ends at the 1500, so I would honestly say that that is the CH2 because there's no other range value that ends before the
Matches that.
1550. So yeah.
Okay.
Okay, the
So this
next one,
bottom
this
one,
one's very obviously OH, but if you don't know that,
this guy here. Yeah.
yeah, if not, OH's frequency is, why did I lose the table? Is 3200 to 3650. So if you're looking at
That's
the
about right. Yeah.
range, you could say it's about from like here to here. Um, that'll help you determine that. And then if you're looking at this one, we're before the 3000 mark. So we could say that it would be before the 3000. Ooh, that could also be a carbon, a C to H
What's
bond.
the yeah, I was gonna say what's the oh no, I was gonna say what's the C to O bond?
The C to O bond
Just a one, not double bond, it's just regular.
is going to be 1000 to 1250.
1,000 to
That's the
1,250.
range. So it'll
Oh,
be like somewhere
you think
here.
it's gonna be this then?
Yeah, probably. This probably is going to be a C to H bond arene, 690 to
Mm-hmm.
900.
Mm-hmm. That makes sense.
So we could say that. Okay. Well, I mean, based off of just this little, you could see the
It's
differences. So
not
you
the
could say
hexane.
number one, and then
There's
number two is going to be cyclohexane.
plenty to write about there.
Yeah. Oh, we're supposed to Are you kidding me?
What's up?
We're supposed to explain the differences.
Oh yeah, yeah. You're just like during the actual. I mean, at least that's the question. What the
Okay,
question asked for. Anyway, okay. Should we move on to something
yeah,
else?
we can move on to something else. So we finished basically exam two, completed
Mhm.
at this moment.
Okay. Do you want to
You
go
guys said,
over? Uh-huh.
hmm? You guys said you wanted to do exam two, or I mean, chapter seven worksheet?
The Chapter 7 worksheet, or because I think that's like the new. I think that's like probably helpful for people.
Yeah.
I think the other stuff is he's trying to see what we did previously. Chapter 5. I mean, I think we can do some questions off Chapter 7 and just see where we
Okay.
end up.
Have you guys started yours? I have not.
What is it? Have I started it?
Yeah.
Yes, I finished it. Um, so I have
Freckles.
a little
Okay.
reference just in case we get lost. Let me see.
Okay.
Let's do like these two, A and B. Let me just write it out. Why not? All right, I'm gonna just put it here. Upload. It's
It's
the free
due
homework for
on
anyone who watches. It's
Thursday.
due like in a few days, right?
Yeah.
Boop, boop,
I
boop.
think it's due on Tuesday, if
On Tuesday.
I'm not sure.
Is that big enough for
It's
us?
due on Wednesday. Okay,
Oh,
just
okay.
Is that big enough?
yeah, that's huge.
Okay. All right. It's more degree of unsaturation. Oops. IHD. IHD equal
Oh, there's more
hydrogen
of this. Could we
minus.
just choose like two to do?
Yeah, yeah, for sure. Let's just use two. I think what's cool is drawing the structures. That's what's
Yeah. The most
honestly the calculation I think is really really fast. It's not too bad. Group
no, yeah,
7,
no, not at all.
1, group 5,
I don't know
wow,
what's wrong with oh, there you go. Okay.
0,
I'm pulling it up right now.
my goodness, -1.
Okay, perfect. Now I have it.
Perfect.
Already. Oh, you already started.
I'm just drawing the
No, you're good. The basics.
oh, and then don't forget the alkane formula is CnH2 times N plus 2. I don't know why I wrote it like that. Okay, cool.
Okay. So for the first one, I'm just gonna say A.
Hmm.
Here, if we set up the chart, I actually have, oops, where is it?
This one's not too bad.
I have 10, or yeah, I'm gonna say this for now. I have 10, and then I have to find it's over 2.
I'll do this bottom one. Is 8 times 2 plus 2, 18. So we do -8 over 2, 10, 5, 2.
Plus 2,
Is it actually 5? It is 5.
10. I don't know why I wrote this in the smallest font possible. Plus 2, so that's 22. Damn. Okay. 10 times 2 is 20, plus 2 is 22. So 22 minus 10, 12 over 2, which is 6. Wait, that has to be.
Minus you have however many are actually here. It's -16 hydrogens.
Wait, oh my God, I'm doing carbons.
Oh, you're doing
My bad.
carbons.
My bad. Oh, don't listen to me.
So you
Okay.
just take your
Sorry, I
yeah,
completely.
no, I get what you mean. Like you take your carbon number and you multiply it by 2, which is 20, and you add 2, so that's 22. So that was right.
Okay,
You're,
but no,
you're
no, no.
just
I'm doing hydrogens, right?
yeah, hydrogens.
Yeah, okay, that was my fault. So
So it was 22, but then you subtract how many there actually are, and
you
there's
subtract
actually 16 there.
Okay, so in that
16
case, then
hydrogens.
I don't know what the hell I did. Okay, never mind. Okay, there's actually 16 hydrogens, which is 6 over 2.
Okay, hold on. The ideal. Oh, wait. Hold on, not this, not this, not this. Oh yeah, wait. Can I not see your numbers? I feel like I'm.
Okay, let me erase everything.
Well, let me erase that. Let me just write here. 22 minus 16. There we go. Like that.
It's my bad. Okay, then in that case, it's 4, and then you do just divide it by 2. Okay. All right. Oh, my bad. This 2 is really ugly.
7 times 2 plus 2.
2 equals 6. And that'll still give me 3. There you go. Yeah, I mean, that's really fast.
Nice.
Okay, this one, what hell?
Whoops. Team. What am I doing? 10. Not this. 14, 15, 16.
5.
Actual equals 10.
Let's see, 5, and then you're gonna have your H2. So N is your carbon number or your hydrogen number?
N is
The number of hydrogens you
N
have?
is N is the carbon. But so the formula for an alkene is this up here, the
Yeah.
CnH2n. So if you want to figure out like how many hydrogens would there be ideally saturated, you multiply by 2 and you add 2, basically.
Okay.
Your carbon number. So
Okay.
for that one, yeah, you would just take 5 times 2 plus 2.
12.
Mhm.
Okay,
So that's
perfect.
your ideal, right?
Yes.
Then your actual, don't forget about the group 5, group
Nitrogen.
6, group
Yeah.
7 elements. Yeah.
So nitrogen. Whoa. I'm just gonna write it right over here. In my 5th group, and then where to go? Is in group 5. So that gives it a negative. That's a -1, right? Yeah.
Nitrogen is -1, yeah. And
Okay.
then your oxygens are both uh nothing.
Oops.
Your oxygens do nothing.
Okay. Group 6. I'm just gonna mark it as a 0. Okay, so I subtract 1 from my final.
From what
Okay.
is actually there. That's terrible. Bad drawing. Oops.
-5. Or -9 is this number, right?
That is your actual, but you're taking
Okay.
away 1, so it's going to be
1.
8.
-1. Oops. Why is this being so complicated? Okay, there we go.
Your brush, yeah.
Okay, 12 minus 8, 10 out of 10
Perfect.
is 4. 4 over 2 equals 2. So 2 degrees. I took way too long
Oh,
on that.
there we go. And then I think we could do like one structure for each, I guess. I think that's too bad. So all you have to do is make sure that you're drawing the right amount of carbons, and then your index of hydrogen deficiency, that unsaturation, that number, you're right, for the first one is a 3. That's going to be how many pi bonds or how many rings, or combination of both. So it could be 3 rings. 10 divided by 3 is kind of a weird number.
That would be like
Like
five.
you could make some freaky structure. You could make like a
Divided by 3 is 3.3.
oh, that's a weird one. Five,
But I
six,
mean, you could just
seven.
do like, you could do
We could do like a maybe
two
a
rings.
and ten. We could do it like this. You could literally do whatever you want.
Yeah, you could.
One, two, three, four, five, six. Uh, actually, no, hold on. I could do two side by side.
You could do a, what is it, a propyl?
There you go. One, two, three,
You could
four,
do a
five, six,
butane.
seven, eight. This is eight.
Yeah.
And we could do this, I guess, for fun. That's it. That's
8,
three
9,
rings.
10.
That's three rings.
Okay.
Right. Sure. It's like a house. I don't think that's a
It
real structure,
is.
but
That's a mansion.
technically, yeah. For five, this is what I came up with here. Oh, you have to remember to include all of your atoms, right? So there's an oxygen there. This was one of the ones I came up with. Double bond. How many carbons? Eight. One, two, three, four, five, six, seven, eight. So let me erase this. So we have the right amount of oxygen, the right amount of carbons, but we just need to figure out our five um, index of unsaturation. I'll do it in like red, I guess. We have five, right? So you have to make, I just chose to do five pi bonds. So one goes on the oxygen because usually there's one on the oxygen, right? That's one, that's two, that's three, that's four, and why not? That's five,
Yeah.
just for fun.
Mm,
So this
that's your
structure here
structure.
has five pi bonds, one, two, three, four, five, eight carbons, one oxygen. That checks out.
Perfect. Should we move on to another one or should we keep going with the structures?
Um, I feel like this is sort of, yeah, I feel like we can move on, right?
Okay.
People can
Okay, thanks.
make up their own structures. I guess it's fun.
Draw their own mansion.
Draw another
Okay.
mansion. Yeah.
So let's see. We can name the following alkenes. We could do number
Could
3, draw the
draw.
structures.
Yeah, let's draw.
Oh, there's not that many questions on here.
Do you feel like the naming we did earlier, right?
We could do like A and D.
Yeah, those look cool.
What the heck
Okay.
is the octatetrene? What the frick?
Octatetra, where is that?
No,
Um,
3D.
boom.
Is that like a tert coming off of it or something? A tert butyl? I don't know. Okay, we'll figure it out as we go.
Tetramethyl.
Okay, I can draw the like base
Tetraene.
structure. I'm just gonna draw as 1, 2,
Oh,
3,
I see.
4, 5, 6. Okay, so I have a double bond. I have 2 double bonds because it says
It's
di,
the diene. Yeah, two double
and then I
bonds.
have on one. So I'm gonna start off right here. Actually, I could do that in a different color. 1, 2, 3, 2, 3. This is my fourth one. Okay, so I did. Yeah, okay. And then you have your dimethyl, which I'll do in green. That's gonna be on my second substituent. And then my fourth one. Okay.
There you
And then the 4E is because of right here. I mean, I don't know if I can like, do I like show that there's an H right here?
go. Yeah. Here I can draw. Okay, that's terrible. The ugliest. There's an H there. Um, one, two, three, four. So we're looking at this left one. We have another hydrogen here hiding, right?
Yeah,
Um,
which
so
E is the same as cis, right?
E is same side. They are
Yeah.
on the same side. So because we have our double bond, and on opposite sides we just pick our biggest groups. So the biggest group is this methyl here instead of the H. And over here, the
Wait,
biggest group.
I thought the E was opposite sides. I thought that was
Oh, E
trans.
is opposite. I'm sorry.
Oh, my
You're right.
bad.
No, you're right. You're right. You're right. E is opposite. I forgot.
So in
Yeah,
that
Z is
case,
the same.
let me switch these.
Methyl pointing up.
Yeah. Barnacles. Whatever. You guys get the point. And then let me change this to black. Thank you for telling us.
Yeah, thank you.
Okay. This is opposite. Okay, the H's are on opposite sides.
E is opposite. You're right.
And
Okay,
then
now we're right. Methyl group there and other methyl group there.
people are gonna watch this and see all the mistakes we make and be like, what?
No, it's what. Like if you know there's mistakes, and that means that you're like super smart.
Yeah. Genius levels.
Yeah, genius level addition.
Okay. Um, okay, we could do
You want to do D?
sure. Do you know what it means by tetra? Like four,
So just like you
is
said,
it this
diene,
coming off of it?
triene, tetraene.
Oh, tetra. Oh, okay. Four double bonds.
Yeah, four double bonds. It's a
Okay, that makes sense. My
double
bad.
whammy, quadruple whammy. Let's see. Uh,
So three
two,
E
two,
and five is the
right here. Boop.
okay. I'll start off, I guess, with the octa.
Octa.
Three. That's five. Six. Eight. So right, one, two, three, four,
You
five.
have to go left to right, BR1,
Okay.
like that BR1.
Yeah. Yeah. Okay. And then we can do, so we have a double bond because right here it tells us we have a double bond on the first one. Oh, whoa. Okay. And then we have a double bond on number three. So that will put us right there.
Mm-hmm.
A double bond on number five. So that's four. That's five. And then a double bond on seven. And that way, if you start from the opposite side, it should actually, I don't know if it will. I shouldn't say that. Yeah, it will give you the same thing.
I just put the methyl groups. I didn't even think about the E or Z, but I just drew them there.
Right, we have to change that. So E is going to be opposite. So if we're looking at this one right here, all right, number three, E. And then your
I think
hydrogen right here.
it's already good, right?
Yeah,
That one's
that's
good to go.
opposite.
So that's done.
Okay. And then
This bottom one is on the same. So one, two, three,
okay, give me
four.
1 second, I'll be right back.
Okay. One, two, three, four, five. Z. Hydrogen is there, and hydrogen is here. So this is not a Z. So what can we do? Make the methyl point down. So I'll make the methyl point down like this. Whoops, that's not a methyl. I would just make the methyl point down. And then I'm gonna redraw this because it's kind of ugly now. Whoops. Um, is that? Yeah, it's really. I'm gonna redraw it. Nice and pretty. Boom, boom. Oops. Perfect. There we go. There's our weird looking. Let me erase that. There we go. That tracks because you have on this double bond, you have a big group on this side, big group down here, so they are opposite. Um, oh my God, no way, it's supposed to be on the same. I need to write this down. Z equals same on the same side.
Okay,
This is what happens when you leave for 2 seconds. I am
you
typing
forgot. It's okay.
this down.
Okay. We honestly need to
Um,
like write that for every single.
yeah, okay, my thing's gonna end in 10 minutes. No, seriously, I almost did it again. I don't, in my head, Z feels like it should be like an opposite thing, you know?
Yeah, I
Like
mean,
it feels right.
whatever. Literally said it. Zame. Is that what you
Z is
said?
on the
Yeah,
same
Zame.
side. Yeah, yeah.
Zame's fine.
Yeah, so
Okay.
this my I redrew here is wrong. Hold on.
Oh, nice.
I think it
Okay.
was already right then. We didn't have to do anything. Was it like that? And you had this, and then methyl group here. There. That is already fine because you have the big group here, big group there, same side. That's your easy.
Okay.
Done.
Yeah. 10 out of 10.
10 out of 10.
10 out of 10. Yeah, because your hydrogen would be right here,
Yep.
making it the same.
Yep.
Alrighty, perfect. Okay. So we did three already.
Um, should we do I feel like the naming is kind so much naming, but I feel like everyone has the naming down,
I
you
would
know?
say naming's pretty good. We could do five, but I will be honest,
Mm-hmm.
I'm not like the best at them. I know like if it's has symmetry, that means it's not as stable, right?
I'll pull it up. Uh, this one, how likely is it to basically how likely it is how let me just take a screenshot. Ba, ba, ba.
Rank the double bonds in each set in the order of their increasing stability.
Stability. We're looking at how many alkyl groups are attached to our double bond.
What helped me for that one is that the more the hydrogen bonds, the less stable it is, if that makes sense.
Oh, okay, that does make sense.
Yeah.
So you just look at one,
So
two.
so basically you have your double bond here, right? And then how many alkyl groups are attached to it? So I'll do it in purple. There's one here, there's another one here, and there's another one there. So there's three alkyl groups. On this one, it has one, two, three, four. Boop. And this one has two.
Wait, what the heck is an alkyl group?
Um, like a CH something.
Let me see. Why am I forgetting this?
Not a very good definition. Alkyl group
It's okay, I'm searching it up.
definition.
An alkyl group is
Yeah,
a
like a
removal of
CH
one
something.
hydrogen, so it's a CH3.
It could be an ethyl, a methane, an ethane. You just have a chain of carbons and hydrogen atoms and you
Oh,
attach
okay. I think I
two.
see
Mhm.
what you meant. Okay, I get it. I get it. Nice. One,
Uh,
two.
two alkyl attached. Oops. So it would be in ranking of stability. We'd have our
So
two, our one, and number three. So the more it has attached, the better.
the more alkyl groups?
The more alkyl groups attached, more stable.
Okay, that makes sense. One, two. Okay, and that'll apply to B as well.
That will apply to B. Let's pull it up. It's pretty fast anyway. What is it? Um, right here. Perfect. There's like 5 minutes left.
Nice.
This one, this one.
Okay, is a
Right
cute.
there, under there.
There you go. Okay, so we have our double bonds. Let me highlight them in red. So this methyl right here is a alkyl group, correct?
Um,
No,
draw on it. I can't
this one
click. Like click on a carbon.
clicked.
That
The
carbon
red.
is part of the double bond, so you have to go one more out.
Oh, what? Okay.
So like that. That's one.
So that's one. Okay.
Mhm.
I take this because I was not trying to do that. Okay. I'm just gonna highlight the
Like
bonds with.
basically, the two carbons that are making up the double bond, don't count those. You know,
Okay, but everything else,
everything,
essentially.
anything connected to those two carbons. Yeah.
Got it. Okay, so it would be this one. And then does this one count if it's at the edge?
Hmm.
Okay. And that's about it, right?
Um,
Am I wrong?
if this carbon is making up your double bond, right?
Oh, then right here?
That one too. Yeah.
Okay. Of course. Okay, so that's three.
3 A's.
Okay. So then you have this one. Wait, no. Yeah, right?
So we're only looking at whatever's connected to this carbon and this carbon.
So then it would be this.
Yeah, so we wouldn't count the far one, the ones like way far out. Just the ones connected to the two carbons, either of the two carbons making up the double bond,
Okay, so it can, okay, I can touch it. I don't know why I didn't think it could touch it.
like that.
Okay, and then for this one, that one.
Yeah. So we just rank from
Two. Oops.
the most to the least. Stable.
There you go.
Ta-da.
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 Okay, thank you for helping me with that one because I didn't know that. And then is there any other questions you guys want to go over? I haven't done it, so I don't like.
Um, I think the rest of it is like just more a ton of nomenclature, which I think
Yeah,
we sort of
which we
have
went
down.
over.
Oh, okay. Should we do, you want to do like one more? Because just to show the frequency things, like just real quick,
For which one?
like calculating wavelength, wave number from, or do you think people have that? Like wave
Wait.
number from nanometers
Oh, we could do
to
that. Which problem?
meters. There was like practice questions somewhere. It's not even that much.
Oh, you mean like on learning checks and stuff?
That converting, yeah.
Oh, okay. Yeah, we could do that. I have actually notes on that.
I'll give you the secret sauce.
I mean, I took it from her lecture notes. Let's see.
There's your.
Okay.
You could just do this. Maybe we don't have to.
Sorry, give me one sec.
Now you're good.
Oh, okay. So the equation.
Literally just this.
Oh, you mean okay, never mind. I had it a little more complicated. Mine's was the
And if you want to
yeah,
do,
mine's was a lot more complicated.
because it's centimeters inverse, you could also do the other way around.
The 1 over delta equation.
Mhm.
1 over
1 over
delta
delta.
and yeah, that's
Oh, I see. Yes. Yeah.
this is centimeter. Oop. Delta is centimeters, and then dividing it by 1 will give you the inverse.
So either of these will work. Oop.
So like if your delta is 4,000,
Okay, we have like 30 seconds, I think.
okay, never mind. There you go. Ta-da.
Ta-da.
Call it a day.
I think we're good. So we're good with, I don't know what else we would.
I think that's pretty much about it. I think anyone can ask questions if they have it in the
Yeah.
Discord.
Yeah, that was like solid 2 sessions. All right, cool.
Okay.